I'm going to start off with your logarithm answers because I just copy and pasted the screenshot from the book into this. So you got to do 11, 12, and 13. So if I look at 11, I can simplify that before I actually start working with logarithms. Right, 2 times 8, that's 16. So this is really 16 to the x, x, is equal to 0.25. And now I can go ahead and take the log of both sides. So I'll do the log of 16 to the x is equal to the log of 0.25. Pop the x out in front. Divide both sides by log 16. So x is equal to the log of 0.25 divided by the log of 16, which punch in your calculator. And if you want, remember, you could use the natural log instead of the common log. It's totally up to you. But you get that x is equal to negative 1/2. 12, we can do the exact same thing. We can simplify what's in our parentheses. So that's really 35, because 5 times 7 is 35, to the a power is equal to 0.585. Now we can take the log. I'm going to combine steps because I know that when I take the log, I'm going to be able to pop my exponent out. So a times the log of 35 is going to equal to the log of 0.585. So a is going to be equal to the log of 0.585 divided by the log of 35, which log 0.585 divided by log 35. Woo, math, enter, enter. That's weird. Nearest 100. Okay, I can do that. So this is going to be negative 0.15. There we go. And last on this page, you can combine the 12 and the 9, alright, because one has an exponent, one doesn't, but I can subtract 12 from both sides. So when I do that, I get 9 to the x is equal to 110. And now I can go ahead and take the log of both sides. Just for fun, I'm going to use natural log. So x times the natural log of 9 will equal the natural log of 110. All right, again, I combined steps. I knew that when I took the logarithm, the exponent would pop out. So x will be equal to the natural log of 110 divided by the natural log of 9, which will give you 2.14 when you round to the nearest 100. If you had done this using the common log and not the natural log, you should get the exact same answer. Okay, that's all you had to do on this. On our exponential worksheet, exponential growth worksheet, we had to do number 10. Okay, and it said that Akeem invests $25,000 in an account that pays 4.75 interest continuously. They give us the formula A equals P times E to the RT. Okay, remember, E is not just some variable, that's the number E, like on your calculator. Alright, and it tells us what A and P and R and T stand for. And it wants to know how many years it will take for my investment to triple. Alright, so he's initially putting in 25,000. Remember, your principal is what you put in. So P is going to be equal to 25,000. E stays E. My rate was 4.75%, which we moved the decimal twice. That's going to be 0.0475. T is what I'm looking for. And I want my investment to triple. So I want $25,000 to triple, so I want to know when this is going to be equal to 75,000. Now I can go ahead and solve for T. I'll divide both sides by 25,000. I get that 3 is equal to E to the 0.0475 T. Okay, I have T stuck into an exponent, so I need to use a logarithm, but be careful. Since I have E, I need to use the natural log. Remember, E and natural log cancel each other out. If you use common log, this won't work. So I need to do the natural log on both sides. So the natural log of 3, now my E is gone. So it's just 0.0475 times T. last but not least, we divide. And put this into our calculator. The natural log of 3. When you do that, don't forget to close the parenthesis on the 3. 0.0475. That is going to give me t is 23.1 years, because I'm pretty sure it said around to the nearest tenth. And that is it. Alright, so they give you the formula to use. You just need to plug into the right places. And remember that you have to use the natural log. Natural log and e are inverses of each other. Boom, baby. And now we are on to the law of cosines. You have to do 1 through 5. And remember, I said to draw a picture. So number 1, we have triangle ABC. So here is my little a, little b, little c. And they tell me that a is 2, b is 3. And they tell me that the cosine of angle C is 1/3, and I'm looking for little c. This is perfect for the law of cosines, because for the law of cosines, you need the included angle. So I have 2 sides and the angle that is included in between them. So this is fine. So I'm looking for little c. So c squared will equal a squared plus b squared minus 2ab cosine c. C squared is equal to 2 squared plus 3 squared minus 2 times 3 times 2. Cosine of C, they straight up told me that the cosine of C is 1/3. Okay, so this isn't the cosine of 1/3. The cosine of C is actually equal to 1/3. So C squared is equal to 4 plus 9 minus 2 times 3, that's 6. 6 times 2 is 12. 12 divided by 3 is 4. So I get that c squared is 9. So c is equal to plus or minus 3, but I'm going to reject negative length, because obviously a triangle cannot have a length of negative 3. So c is equal to 3. Boom. Moving on to number 2. We also have another triangle labeled A, B, and C. Very creative. So here has to be my little a, here has to be my little b, here has to be my little c. They tell me little b is 3, little c is 6, and angle A, so this is the actual measure of this angle, is 120. Alright, find little a. That's perfect. I have 2 sides and the included angle, the angle in between them, so I can use the law of cosines. Right? I'm looking for a, so this is going to be a squared. Also, whatever, well, hold on. A squared is going to be equal to b squared plus c squared minus 2bc cosine a. Alright, remember, whatever's on the ends have to match. So this, which is a, has to match whatever you're taking the cosine of. Then we can just plug in. A squared is equal to 3 squared plus 6 squared minus 2 times 3 times 6 times the cosine of 120. That's 9, that's 36, that's 36 cosine 120. Notice I'm simplifying as I go. It is going to make your life a heck of a lot easier if you simplify as you go. Okay, you cannot combine the 45 and the negative 36. They're not like. Okay, the 36 has the cosine attached to it. Cosine of 120, we can figure out the cosine of 120 using our special right triangles. Alright, because cosine 120 has a reference angle of 60. So I'm going to take into consideration the fact that this has a reference angle of 60. And I say, okay, well, that means that the cosine of 120 is equal to the cosine of 60. I just need to make it negative because 120 is in quadrant 2 and cosines are negative in quadrant 2. So then, looking at my special right triangle, remember, hypotenuse is always 2. The cosine of 60 is a over h, so it's 1/2. So a squared is equal to 45 minus 36 times negative 1/2. So a squared is going to be equal to 45 plus, what's 36 times 1/2? That's going to be 18. And 18 plus 45 is going to give me 63. So a squared is equal to 63. So a is equal to the square root of 63, which is going to be 3 square root of 7. Cool. All right, moving on. And I apologize, I just put a crack on my mouth to start. Number 3. Number 3 says we're talking about an isosceles triangle. Isosceles means it has 2 equal sides. Alright? I want to find the measure of the base. And like I said, label. Alright, it helps. So in this case, the base of my isosceles triangle, I labeled it B. How appropriate. The vertex angle, well, this is my base, these are my base angles. So my vertex angle is up here. This is going to be 84. And each leg is 12. So A is 12 and C is 12. Doesn't look as obvious maybe, but this is still perfect for the law of cosines. You get 2 sides and the included angle. So we can use the law of cosines. So B squared will equal A squared plus C squared minus 2AC times the cosine of 84. And you might be thinking, cosine of 84, I don't know the cosine of 84. Well, in the problem it says to round to the nearest tenth, so obviously this is going to be a little weird. So B squared will equal 12 squared plus another 12 squared minus 2 times 12 times 12 times the cosine of 84. That's 144 plus 144 minus 2 times 12 times 12, 288 times the cosine of 84. So that's going to be 288 minus 288 cosine 84. Notice I'm not putting anything in yet in the form of a decimal. I know that the cosine of 84 is going to be gross, so I'm going to wait till the very last second to actually punch it into something. I'm going to have to take the square root. So B is going to be equal to the positive square root of 288 minus 288 cosine 84. Put it into your calculator like this. Square root 288 minus 288 times the cosine of 84. Boom. B is equal to 16.1 because we're rounding to the nearest tenth. Alright, don't put something gross into your calculator until you absolutely have to work with that decimal. Moving on to number 4, we are almost done. Triangle ABC. A is equal to 5, B is equal to 9, C is equal to 12. I want to find the cosine of angle A. Alright, well if I want to find the cosine of A, that means I should probably use the version of cosine of the law of cosine that has cosine A in it. Well, if I want cosine A in it, that means that it has to be A squared is equal to B squared plus C squared minus 2BC times the cosine of A. Right, the ends have to match. And then I can plug in 5 squared is going to be equal to 9 squared plus 15, not 15, plus 12, my bad, plus 12 squared minus 2 times 9 times 12 times the cosine of A. So that's 25, my board's starting to get weird. 25 is equal to 81 plus 144 minus, I don't know what 2 times 9 times 12 is. 2 times 9 times 12, 216 cosine A. So 25 is equal to 81 plus 144, that's 225, minus 216 cosine A. I'm trying to find the cosine of A, so I'll subtract 225 from both sides. That will give me negative 200 is equal to negative 216 times the cosine of A. I got the cosine of A times some stuff, so I'll divide. Negative 200 divided by negative 216 gives me 25 over 27 when it's simplified. And is that what I wanted to find? Yep. All right, it didn't actually ask me to find angle A, it asked me to find cosine of A, so I'm done. Last but certainly not least, number 5. Find to the nearest minute the measure of the vertex angle of a triangle whose sides measure 3, 3, and 5. So A, B, C, A, B, C, 3, 3, 5. Cool. All right. Now notice 2 of these sides are equal. This and this are the same. And depending on how you labeled your triangle, maybe it's not A and C, maybe it's A and B, whatever. All right. But since this is a triangle and 2 of the sides are equal, this isn't just any old triangle. This is an isosceles triangle, right? So if these 2 sides are equal, that means the 2 angles across from them are equal. Those are my base angles, okay? But I want to find my vertex angle, so I'm trying to find angle B. All right, so there's a little to this. You got to actually figure out which angle you're looking for. And remember, depending on how you labeled your triangle, it might be a little different, okay? But whatever 2 sides you let be equal, so in this case, I let A and C be equal, that means I need to find angle B. All right, so I want to find the measure of the vertex angle. So if I want to find out something about B, that means angle B, I need to be talking about the cosine of B. So I need to use the version that's B squared. Okay, I need to use the version that's B squared because that's the only one that talks about angle B in some way. So then I can just plug in 5 squared is equal to 3 squared plus 3 squared minus 2 times 3 times 3 times the cosine of B. 25 is equal to 9 plus 9 minus 18 cosine B. I know this might seem a little like I'm writing a ton, but it helps. All right, it helps to write every step. It's easier to ensure that you get partial credit. I know I say this all the time, but that's because I mean it. So negative 7/18 will equal cosine B. Now in this case, I'm not done. All right, because it doesn't ask me to find the cosine of the vertex angle, it actually asks me to find the vertex angle. So I actually need to find B, not cosine B. So I will do the inverse cosine of negative 7/18 to find B. Put that in your calculator, and you will get, and what are we rounding to? To the nearest minute. You will get that B is equal to 112 degrees 53 minutes. Perfect. I do want to point out one thing. B being equal to 112, that's fine, because if I look in this picture up here, we say that this is about 112, I could easily find angle A and angle C. That will be 180 minus that, because all the angles have to add up to 180, and then divide by 2. This would be about 33, and this would be about 33. That's fine. Okay? But coming back down here, and if I want to look at this line, hopefully someone is saying, wait a minute, cosine being negative, that could happen in quadrant 2, which is what I found, but that could also happen in quadrant 3. Aha! Okay, that's a good point. But you gotta remember, if I'm in quadrant 3 means I'm somewhere in between I'm somewhere in between 180 and 270 degrees. So if I found the quadrant 3 possibility for this, it would have to be bigger than 180 because I'm between 180 and 270. And that's silly because if this angle is bigger than 180, I can't have a triangle because all of the angles in the triangle have to add up to 180. So I can't have one angle be bigger than 180. So in this case, even though there are two different possibilities for this, since I'm in a triangle, I only care about the quadrant 2 possibility, not the quadrant 3.